In this video, I will explain you what will happen when we are keeping a dipole in an electric field. So I am going to consider two types of electric field here. One is uniform electric field, one is non-uniform electric field. So these green colored lines represent my electric field. So uniform electric field means electric field at every point is the same. Everywhere here it is the same. But here electric field lines or electric field intensity at these points are not the same. So here the value is higher and here the value is lower. You can consider otherwise as well. But anyway, electric field at this point and at this point it is different. Okay. Now when E is uniform, electric field is uniform. When we are keeping a dipole in this way, we know that the moment you are keeping a charge in an electric field, it will experience a force. So plus Q will experience a force of QE in this direction. And positive charges will experience a force along electric field. We have learned that, right? And what about the case of negative charge? It will be experiencing a force opposite to the direction of electric field. So electric field is here. It will be experiencing a force of QE here. Now what is the net force? See, QE on the rightward direction and QE on the leftward direction. So net force is equal to 0. Which means it is in translational equilibria. It can neither go forward nor go backward because net force is 0. But see, this is a coupled, right? In the same way we are opening a lid. See, one person is pulling it in this direction, another person is pulling it in this direction. What will happen? The whole thing will rotate. And how to get the value of couple here? Couple is nothing but torque. Torque is nothing but any of the force. So QE, force into the perpendicular distance. We need the perpendicular distance in between line of action of force. So this is the line of action of both the forces. We need this distance. This is the perpendicular distance. So let's say the angle between E and this one, if it is theta. The angle in between electric field and what is this? Dipole moment. So dipole moment will be minus Q to plus Q. So angle in between these two, if it is theta, then we can easily get the value of this. So if we know that the distance in between charges in a dipole is 2a. So force into perpendicular distance, this is the perpendicular distance. Let's say the perpendicular distance is AB. So force into AB. Now what is force? QE. And what is the value of AB? If this angle is theta, then this will, see, these two are parallel, right? If this angle is theta, this one also will be theta. See, two parallel line, and if this angle is theta, this will also be theta. Now we know this one is 2a. We need to find here. So this is opposite and this is adjacent, which we will use. We can use sine theta. So from here, sine theta is equal to this opposite divided by hypotenuse. Okay, so opposite is AB and hypotenuse is 2a. This is a Pythagoras triangle, right? So opposite by hypotenuse. So opposite AB is equal to 2a sine theta. So that we will substitute here. So QE into 2a sine theta. Now I can take E here. I will keep E here and 2aq. 2aq is nothing but, what is 2aq? This is dipole moment P. So this can be written as PE sine theta. So PE, a value and other value sine theta can be written as P cross E. So P cross E is nothing but PE sine theta, torque. Now with this torque, it will rotate. Now we will draw a table. Angle, and torque. When theta is equal to 0. So theta is equal to 0 means minus Q here, plus Q here, and this is the direction of dipole moment, minus Q to plus Q. And electric field is also in the same direction. So when the theta is equal to 0, P is sine 0. What is sine 0? 0. Now theta is equal to 180. Same case, but positive charge will come here, plus Q, and minus Q will come here. Electric field is in the same direction, but dipole moment is in this direction, minus Q to plus Q. But still, sine 180 is 0. So P is sine 180 0. Same thing. Now theta is equal to 90 and theta is equal to 270. Now if theta is 90, that is this case, that is the maximum torque, minus Q and plus Q, dipole moment, and we have electric field in this way, 90 degree. Same case for 270, plus Q and minus Q, electric field in this way, dipole moment in this way. So this one is 90 and this one is 270 case. So in both the case, torque will be maximum. So it is very clear here, right? Perpendicular distance will be more here. As it rotates, the perpendicular distance will gradually come to 0. So this is maximum, that is PE and PE in this case. So in a non-uniform electric field, it is no difference from this, but the only difference is, see here, if electric field is more, say for example here electric field is more, here electric field is less, non-uniform, value of electric field is not the same. So here this will be Q into higher electric field and this will be Q into lower electric field here. So what will happen? Net force is not 0. It is having a higher force in this direction. Okay, see, higher force in this direction, lower force in this direction, till it is having torque. So this will create, these two forces will create a torque, and with that torque it will rotate, and also we have a non-balanced force here. This is higher and this one is lower. So this has a tendency to move forward. It's not, the translational equilibrium is not achieved here. Higher force and lower force. So this will move and also rotate. So how it will go? See, in this direction it will go forward. It will rotate and move. But this one will simply rotate. Okay. That's it. Thank you.